Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box there's some mystery math and your challenge is to figure out what that is. It's a Friday, so this math is particularly challenging today. You can use the link in the description to try this out, and when you think you know what it is, come on back and see if we get the same thing. Alright, well, let's begin. I'm going to put it in a 0. And 0 gives us 0. Okay, how about a 1? Get some kind of decimal there. Okay, let's try 2. Oh, and 2, we're way down. Maybe this is trig, maybe this is an odd parabola. Let's try a 3. 3, we're coming back up again. How about a 4? Okay, so it looks like it's going up and down and up, so maybe this is trig. Let me try some negative values. Okay, and how about a negative 2? Okay, so this looks pretty similar, like the pattern is continuing up and down and up and down. So let's think for a minute about trig functions. So it looks to me like this is going to be, well, something to do with sine or cosine. The tangent would be flying up towards infinity or down towards infinity. This doesn't appear to be doing that. It looks like we've got the waveform here, although the shape is a little different than we're used to seeing, or it seems so right now. So in those trig functions, um, we're taking the angle from the center of the circle out to some point on the circle, and then the coordinates, the x and y of the coordinates of the endpoint of that line that the angle would make, the x is your cosine and the y is your sine. So at an angle of 0, we'd be right here, and the point would be 1, 0, so our sine would be 0. So it looks like at 0 we're at 0. So is this sine? Okay, let's think about what happens next. So at pi over 2, we would go all the way up to the point 0, 1. So sine would be at its highest, would be at 1 at pi over 2. And if we put in a, let's put in a 1.5. Yeah, what we're getting is something close to 0 again, 0.14. Which is odd. What if we put in an approximation for pi? So how about 3.14? Aha. And at pi, we're also really close to 0. So now that's what you would expect for the sine here, because pi is way over here and on the other side here. So here's pi. So again, we would be at the point -1, 0, and we would be at 0 for sine. But we were at 0 up here too. So what is going on there? It looks to me like this is getting squished together, kind of accordioned together, and we're going through this waveform faster than we normally would. It's almost, well, actually, so to go from 0, where we started at 0, which is where you'd expect, and then in just pi over 2 to get to 0 again, it's almost as if we went twice as far. And then if we went twice as far again, we would get to 0 again. And that seems to be what's happening here with this one. And it looks like the pattern continues on the other side. So how do you go twice as far compared to sine of x? Well, you would multiply that x. So this might be f of x equals the sine of 2 times x. So let me explain how that would work. If you're at pi over 2, you'd put in pi over 2 for x, you'd multiply that, and you'd end up at pi, and that would put us back at 0. And that seems to be what's happening here at pi over 2. And then, of course, when you put in pi, you get a 0, 0 as well. And well, but that would put pi times 2 would put you at 2 pi, so you'd be right back to the beginning. So I think that's what's happening. From the visual, it's confirming this idea because it does look squished so that the wave is happening twice as often in the same space as it would for sine of x. So I'm going to go ahead and check this and see if we're right. Yeah, there it is. So that's the sine of 2x. And let's just go ahead and graph this as well. It's kind of an interesting looking graph. And there it is. So it's that typical waveform. It's just compressed into a smaller space. Well, how did that go for you? I think that was pretty tricky. Did you get trig? If you got that far, give yourself a pat on the back and let me know how it went. Thanks, everybody.